In this video, we will delve deeper into calculations involving pH and pOH. We will first learn the meaning of measurements such as pH and pOH. We will then talk about the pH scale and where some common acids and bases sit on this scale. Finally, we'll go over a sample exam question where we will apply our understanding of pH calculations. A brief reminder that the kW of water is 1 times 10 to the minus 14. We will be using this auto-ionization constant in this video. So let's jump right into it. The auto-ionization of water we just mentioned provides a foundation by which we can understand the meaning of pH. Most students, in fact most people, have some understanding that a pH value relates to some information regarding acidity. We now understand that acids are characterized by the hydrogen ion or the hydronium ion if the hydrogen ion is shown to be associated with a water molecule. It is time to introduce the definition of pH and pOH. The pH is the negative log of the concentration of hydrogen or hydronium ions, and similarly, the pOH is the negative log of the concentration of hydroxide ions. Later in this video, we will also find out that in water at 25 degrees Celsius, the concentration of hydronium ions equals the concentration of hydroxide ions equals 1 times 10 to the minus 7 moles per decimeter cubed. Before taking a chemistry class, many people also understand that water is considered neutral with a pH equal to 7. Using the definitions of pH and pOH and the concentration of the hydronium and hydroxide ions in water, we can see that a pH of 7 represents this many moles of hydronium and this many moles of hydroxide ions in water. The pH scale gives us a useful way to describe the acidity or basicity of substances and is based upon the hydrogen ion concentration and the hydroxide ion concentration. The visual below shows the approximate pH values of a variety of household substances. In general, substances with pH values less than 7 are considered acidic, and the lower the pH value, the greater the hydrogen ion or hydronium ion concentration. Substances with pH values greater than 7 are considered basic, and the higher the pH value, the lower the hydrogen ion or hydronium ion concentration. As seen in the equation for the auto-ionization of water and the Kw expression, the concentration of hydronium ions and hydroxide ions are related. In water, these concentrations equal each other and equal 1 times 10 to the minus 7 moles per decimeter cubed with a pH and pOH value of 7. However, substances that are more acidic have a higher concentration of hydronium ions and therefore have a lower pH value. The hydroxide ion concentration also must be lower, resulting in a higher pOH value. The general rules for pH and pOH calculations are as follows. The Kw still applies and remains unchanged if our temperature remains constant. What we can do is take the negative log of all the terms in this equation and end up with this equation. Remember, the negative log is the p in pH and pOH. So we end up with this useful equation in the end that the pH plus the pOH will equal exactly 14 at 25 degrees Celsius. These rules make calculations related to pH fairly straightforward. Let's take a look at an example question. Although ocean water is considered to have a pH of about 8.1, climate change progresses and CO2 concentrations in our atmosphere increase and the oceans are acidifying. The lowest ocean pH recorded in recent history is 7.4. What is the hydronium ion concentration, the hydroxide ion concentration, and the pOH in the most acidified areas of our oceans, assuming an average temperature of 25 degrees Celsius? We're given the pH by the question here, and we want to figure out the concentration of hydronium ions. We learned earlier that the negative log of the concentration of hydronium ions gives the pH. What we can do is get the concentration of hydronium ions if we have the pH by canceling out the log term in this expression. This is done by taking 10 to the power of the negative pH. 10 to the power of negative 7.4 gives us 3.98 times 10 to the minus 8 moles per decimeter cubed. To figure out the concentration of hydroxide ions, we can take the expression for Kw and rearrange it for the concentration of hydroxide ions. So the Kw divided by the concentration of hydronium ions is the concentration of hydroxide ions. If we plug in the values we know, this gives us a hydroxide ion concentration of 2.51 times 10 to the minus 7. And finally, to figure out the pOH, we can use the equation we derived earlier, which is that the pH plus the pOH equals 14. So the pOH is 14 minus the pH, giving us a 6.6 as the pH. Just a note that this is not the only approach to this question. You could have used, for example, this equation first to figure out the pOH and then the concentration of hydronium and hydroxide ions. And that's it for this video on pH and pOH calculations. To summarize, we learned that the pH is the negative log of the concentration of H+ ions, and that the pOH is the negative log of the concentration of hydroxide ions. We also learned that basic species have a high pH and acidic species have a low pH. We also used the value of Kw in some pH calculations. For example, here where we could determine the hydroxide ion concentration from knowing the hydronium ion concentration and the value for Kw. And finally, we learned the useful equation that at 25 degrees Celsius, the pH and the pOH added together equals 14.